Hey guys, welcome back to the channel. Hope you all are doing well. So the problem that we will be discussing today is again based on linked list. I'll just show you the problem statement. Before that I need to check if we are live. I think we will be live. Okay, so the problem that we are going to discuss today is implement queue using linked list. So it's a basic problem and very good problem for you to get a good understanding on linked list. You know, problems like implementation we see in linked list, also we see in stacks and queues, right? Implementing stack using queue and such things. So basically I always suggest these are tagged as basic questions, but these questions should be done on priority whenever you come across these questions, because this tells you how good understanding you have regarding that particular data structure. Fine, so I think we are live. Okay, so let's discuss this problem statement. What is a queue? You know queue, what kind of a data structure queue is. Now we know how we implement a queue using an array. Okay, we know implementing queue using other data structures, but this time we have implemented queue using stack also. So how can we implement a queue using linked list? So what logic goes behind this is that, what is a queue? First of all, queue is a data structure that follows this order of first in, first out, right? So we have to just maintain this property of a queue using a linked list, as simple as that. So for example, you have a linked list. What do you have in a linked list? You have a data and the address of the next node, right? For example, this is 10, and then this is some address which is pointing to your next node, right? What do we have in a linked list? So if this is a linked list, what address we have prominently, that is the address of the head node. That is the only key to our linked list. Using that head node, we access the other data, other nodes of the linked list. Now for example, this is some 20, a node with data 20. Now its next is pointing to another node whose data is, let's say, 15, right? And its next is pointing to some other node whose data is 25. Fine. And its next is null, for example. Let's say this is your linked list. Now if I want to implement this property of a queue, FIFO, that is first in first out, can I do that? Let's see. What is if I ask you to do a pop operation? Basically, when we are trying to implement a queue data structure using linked list, so we have to focus on two things, that is pushing the elements, which here we are going to, that is basically we are doing NQ and DQ, right? QU, these two operations we want to do, right? So when we do NQ, that is fine. Whenever we add a node, we add at the end, right? End of the linked list. And when we remove the element, we should ideally be removing the element from the head, from the front of the linked list. So let's call them front node. Okay, if I ask you to perform DQ operation, okay, so DQ operation, you can clearly see that I am asking you to perform DQ operation. So you already have the address of your head node, right? Head is pointing to 10, and let's say I have taken an extra variable here of node front, which is pointing to head as of now. So I will simply say that, okay, I have the address of my front node. I can take its data and return that value for my DQ function. Okay, I can easily return front dot data. Fine. But before doing that, I have to make sure that I have the address of the next node for my next operation. You getting my point? So right now I'm not writing the code, I'm just trying to make you understand that this is something we can do in how much of time? Over of time. Why? Because we will always be having the head node with us handy when we are talking about a linked list. That's the key to a linked list. So removing the node from the front of a linked list is something that we can easily do in O1 of time complexity. Let's talk about NQ operation. If I want to perform NQ operation, that means I am trying to add a new node at the end of my linked list. But the problem here is that Do I have the address of this tail node right now with me? No, I don't. The only thing that I have in my linked list is the address of the head node. So what will I need to do? That while my head or anything, let's say temp, I can say temp is pointing to head node right now, for example. While my temp is not equal to null, or I can say temp dot next is not equal to null, so that I know what is the address of the last node. Dot next is not equal to null. Do temp equal to temp dot next, right? But the problem with this is that I will have to traverse each time through all the nodes present in the linked list, right? So right now, for example, temp is here, okay. Temp dot next is not null, I move to this, then my temp moves to this, then temp moves to this. Now the temp dot next will be null, so I will come out of the loop. When I come out of the loop, I will say that temp dot next will be, I will add a new link which will be, for example, whichever node you are passing, right? So that will be, for example, node, I say this, whatever node it is, okay, let's say data is 30, so it will be this temp dot next is pointing to this new node, for example, new node, whatever it is, and I have formed this link, and then that is all that I have done during enqueue operation, right? But the thing here is that you can definitely do this thing very straightforward, but I want to perform enqueue operation also in O1 of time complexity. So that is what we want to do. And in order to perform that, you can see DQ can always be done in O1 of time complexity. Why? I'll write the DQ operation first. So if I talk about DQ operation, what will I have? I just have to actually return the data of the front node, right? So I will have, let's say, a front node which is pointing to the head of the linked list. So first I'll take some variable in which I will store the data of this front node. So int x, for example, is equal to front dot data, right? Now I will move my front to the next pointer, next node, because I know this has to be removed, this link has to be broken, so I should have the address of the next node. So front equals front dot next. I hope you will understand what I'm trying to say. And then what do I have? And then I just simply return this x, that's all. Fine. Front comes at front dot next. Now again, if I ask you to do DQ operation, you will have the address of the front node. You can easily remove 20 and now your front will be pointing to 15. So DQ is always going to take O1 of time complexity. But NQ, if I ask you, for example, front is here and I want to add 30, then from front you will take a reference to front, then front dot next, and then its next, and then its next will be the node that you want to add. So I want to cut down this operation to O1 of time complexity. So what can we do in this case? See, in this case it's going to be again simple. Just one extra thing I'm going to do, that since we have the address of the front node, let's keep the address of the last node as well each time we are doing the enqueue operation. For example, let's do it one by one. Right now I am showing you the enqueue operation. Okay, this is the head node. Fine. Right now you do not have any nodes. I am asking you to do enqueue of 10. This is the node that I'm giving you. Okay, in enqueue operation you can see what I think we are giving the data. So in push operation I am giving you the data. So first of all you have to create a new node whose data is 10, right? So this is the push operation that I'm writing here. It is taking int a. Fine. So first of all, let's create a new node. Here the node is named as q node. I'll write node here. So node, let's say temp equals new, the node and data which we are passing. So basically right now the current scenario is I have created a node whose data is 10 and this is referenced by temp. Now I will ask if I will have two nodes. As you can see here, I already have the function has already given me two variables of node type front and rear. So I will keep the address of the last node by rear and the first node by front. I will check if my front node is equal to null. That means right now there is no node in the linked list. Okay, so in that case what will you do? Your front and rear will both point to your temp node, as this is the first node that you are going to add to your linked list. So right now your temp is also this, your front is also this, and your rear is also this. Okay, in else case we will write the else case when I will add a new node. Now let's say your a was 10, now I want to do push of 5. Okay, so now your data is 5, you again create a new node. Again I have created a new node whose data is 5. Okay, and this now temp is actually pointing to this. This is my temp node which is pointing to 5. I am asking, is my front null? No, front is already pointing to 10. Okay, and rear is also pointing to 10. That's so I'll come at the else part. What will be my else part? That means I already have some node in my linked list. I will ask in the else part, I will ask my rear dot next, because rear node will be the node which will be pointing to the last node that was added to my linked list. Right now I had one node, that is why rear and front are pointing to the same node, but I'll take rear for this purpose. So rear dot next, now I have actually formed a link from rear to temp. Rear dot next should be pointing to the node that I'm trying to add, and then I will make rear point to rear dot next, because rear is supposed to store the address of the last added node into your linked list. So this link has been created now, and your rear from here comes to the temp node, right? Fine. Okay, this is how. Now if I say push, I ask you to do push of 20, for example. Now your data is 20, your new node has been created by data of 20, right? And temp is pointing to this 20. Fine, this is your temp node. Front, if front is null, which is not the case, that means you already have some nodes in your linked list. Now you go to the else part, create a link from rear dot next is pointing to temp, rear comes to this rear dot next, and that is how you are creating a linked list. And now you see that your NQ operation is also taking over of time complexity. If I ask you give a DQ, I am asking you to perform DQ operation. So in DQ operation you are going to do nothing, you will just store the data that I have already written here. This is your DQ function. Int x is front dot data. What is your front right now? 10. So this front will be stored in x. Your x is right now 10, and front goes to front dot next, which is this, right? So front is pointing to 5 right now, rear is pointing to 20 right now, and you return your x. So this link has been deleted and you have returned 10. Now again if I ask you to do DQ operation, your front is pointing to 5, so your x will be 5 now, your front points to front dot next, and that's all, you return this. Okay, got it? Even if you don't delete the link, at least you return the data. That is the intent. Although the links will be in place. See, links are not deleted. It's not like now 10 dot next is pointing to something else. It's just that the variables, the pointers that we have used to store the data in the current scenario of the linked list, which is right, so that will be shifted. There is no pointer, that there is no variable that is having the address of this node, no variable having the address of this node, because front is also pointing to this, rear is also pointing to this, and temp is the node itself. So got it? So this is all about this problem. So we have actually implemented a queue using linked list. We have performed two operations, push and pop, and both taken O1 of time complexity. That is all about it. Fine. I'll just quickly check if you guys have any doubts in this. Okay, Mrinal, I'll come to you after discussing this problem statement. See, if you are looking for a switch, or if you are looking to do better in your company, it has two different answers. If you are looking for a switch, you definitely need DSA. DSA is the most important thing. And how much time you have? 3 months, so you are a fresher. Okay, so DSA is something that you should focus on, and DSA depends on consistency. You have to be very consistent with everyday practice, right? And you can follow this SD sheet, which is very nicely curated by GFG. Follow it, try to solve 4 to 5 problems a day, and that's how you can end up being good at DSA. This is first thing. Second thing is, if you want to do better in your organization itself, try to work on your DSA. Plus extra, what you need to do, you should work on more on your development part, on the things that you're working in your current organization. So anyway, coding and DSA and development. DSA should be prioritized in case you're looking for switch, and if you want to be into development field, prioritize that. That depends on your priorities. Okay, so let's move to this problem. Now, as I told you, we already have front and rear with us. Okay, let me just find it. Okay, fine. So see, the node here is Q node, and this is Q node. I am creating a new node, QUEUE node temp. I am performing the push operation, new QUE, and data is A. If front, that means front and rear are pointing to the same node, that is your temp, equal temp. Okay, in the else part, handle it using your rear dot next equal temp, and rear equal rear dot next. That's what you are doing. Okay, rear dot next equal to temp, and rear equal to rear dot next. That is done in your push operation. Let's talk about pop operation. If your front, I want to remove the front, I want to return the data of my front node. If front is equal to null, then obviously your linked list is empty and you return -1. That means your queue is empty, you return -1. In the else case, what do? We don't need to write else explicitly. Okay, int x equal to front dot data, move your front to next pointer, front dot next. Okay, and return x. Let's see. That's all about this problem, guys. So we are done with it. If you guys have any doubts, I hope you got your doubt is clear, Mrinal. If you have any doubt in this question, let me know. Else we are done for this problem, and let's wrap it up then. Okay guys, then see you all in the next lecture. Till then, take care and keep coding. Bye bye.